All right, example 2. Again, please read it while you have the video paused and then unpause when you're ready to solve it. So we have a roller coaster car moving at 13.8 meters per second at the bottom of a loop, and we want to know what is the normal force at the bottom of the loop. So we've got a circle, okay, and this box is the roller coaster car, and the roller coaster car is going to have two forces acting on it. So again, gravity is going to be down because gravity is always down, but remember the normal force goes from the surface towards the object. So for the normal force, this is my surface here, okay, so I'm drawing away from the surface and towards the roller coaster cart like this. So that's the normal force. Now, when you have two forces in opposite directions like this, you know to make the one that points to the middle of the circle bigger, and that's because we know that the net force always has to point towards the middle of the circle in circular motion. And so that means whatever force points to the middle of the circle, in this case it's the normal force, has to be larger than forces that don't point to the middle of the circle, in this case gravity. Okay, so when we do this, we're going to make upward forces positive, downward forces negative. We're going to write down that Fc is the sum of the forces. So Fc is Fn plus Fg, and we're looking for normal force. So we're going to do Fc minus Fg when we rearrange for the normal force. And again, we're going to go ahead and calculate Fc and Fg. So Fc is mv squared over r. Now when you do this, don't put negative values in, just keep everything positive. And so the mass of the roller coaster car is 4,800 kilograms. The speed is 13.8. Square that. And the radius of this loop is 10 meters. So let's calculate that. So 4,800 times 13.8 squared over 10. That gives me an Fc of 91411.2 newtons. Now I'm going to write in the direction of Fc. So Fc is always towards the middle of the circle. So when the roller coaster car is at the bottom of the circle, Fc is towards the middle of the circle, or in other words, it's up. Okay. Now I'm going to calculate Fg. So Fg is mg, so 4,800 kilograms. And because it's down, I'll make 9.81 negative. So 4,800 times negative 9.81, that's negative 47,088 newtons, which remember this is the same thing as 47,088 newtons. Down. Okay, so now we're going to do this step right here that I'm circling. So the normal force is the centripetal force minus the force of gravity. So normal force is the centripetal force, 91411.2 newtons, minus the force of gravity. But because the force of gravity is down, we're making it negative, 47,088. And so, doing that in my calculator, I get 138,499.2 newtons. And so for my final answer, for the normal force to two significant digits, this is going to be 1.4 times 10 to the power of 1, 2, 3, 4, 5 times 10 to the power of 5 newtons. And because it was positive, also from our free body diagram, we know that the normal force here is